Okay. Hello everyone. So in today's lecture, we're going to see about elements of parallel computing. So in previous lecture, we have studied what is cloud computing, right? The work of cloud computing, advantages and disadvantages. So in today's lecture, we see elements of parallel computing. As you can see in the screen, distributed computing. We ये इसकी study हम लोगों ने already कर चुके हैं, right? Distributed computing. What is the processor, memory, task कैसे divide होता है सब tasks में, right? So in today's lecture, we will see about parallel computing here. Okay. So parallel computing, why we use parallel computing? You know very well serial computing means which happens in sequence wise, and in parallel computing is you can say that it is the use of multiple processing elements simultaneously for solving any problem. Okay, to solve any problem we are using the parallel computing. So problems are broken down into instruction and are solved concurrently as each resources, right? So that has been applied working in the same time. So advantages of parallel computing over the serial computing, you can say are as follow, like मतलब serial computing से better parallel computing why क्यों है और why, what is the advantages over the parallel computing, right? So here serial computing मतलब parallel computings over serial computing are as follow. First, it save time and memory, as many resources working together will reduce the time and cut potential cost, because what divide tasks divide होते हैं, but serial computing we have to do tasks in sequence one after one, but in parallel it save time. Okay, and many resources can divide. Okay, so you can say that it can be impractical to solve large problem on serial computing. Okay, so problem on serial computing, well, it can be impractical solve the large problem. Okay, then it can take advantages of non-local resources. When the local resources are finite, the serial computing wastage the potential computing power. Thus, parallel computing makes better work of hardware. Okay, so types of parallel computing here. Let's see, discuss first types is bit level, bit level parallelism. Okay, so this is the first type of parallel computing. It's bit level. Okay, so this is the first type. So in bit level parallelism, it is a from parallel computing, which is based on the increasing processor size. It reduces the number of instruction. Okay, so bit level में वो number of instruction को reduce करता है. Okay, processor size, it reduces the number of instruction that the system many number of instruction को reduce करने के लिए हम लोग we are using this parallel computing. So you can say that it is a form of parallel computing which is based on the increasing processor size. It reduces the number of instruction that the system must execute in order to perform a task on large size data. Okay, then example, consider a scenario where an 8-bit processor. Okay, so okay, so consider a scenario. Let's say consider 8-bit processor must compute the sum of two 6-bit integer. It must first sum of 8 lowest order bits and highest order bit, right? Then there's require two instruction to perform the operation. That is 16-bit processor can perform the operation with just one instruction. Means 2 bits 16-bit में is divide किया गया है. ओके मतलब साइज तो वही है बट उसको इंस्ट्रक्शन को डिवाइड किया गया है 8 by 8 से. फर्स्ट हायर लेवल टू you can say lower level. ठीक है, so this is a bit level parallelism here. Means here it is a form of the parallel computing which is based on the increasing processor size. It reduces the number of instructions that the system must execute in order to perform a task. मतलब task perform करने के लिए number of instruction को ये divide करते हैं. It comes under the bit level instruction. Then next is the instruction bit level parallelism. Sorry. Now instruction level parallelism. So let's discuss about instruction level. Okay, instruction level. So here in this instruction level, okay, so this is the instruction level of parallelism. So this is the next point. So you can say that instruction level parallelism here, a processor can only address less than one instruction, okay, each clock cycle phase. So the group which are later on executed concurrently without affecting the result of the program, this is called instruction level. मतलब processor can only address less than one instruction. मतलब जो भी instruction given है उसी instruction को processor call करेगा. So which is comes under the instruction level parallelism. Then task parallelism. ठीक है, task level. Then next is a task. Okay, so in task level parallelism, here the task, the decomposition of, you can say decomposition of tasks into subtasks, and then allocating each of the subtasks for execution. मतलब टास्क को सबटास्क में allocate करते हैं और फिर उसको execution के लिए कॉल किया जाता है. Okay, then so you can say that the composition of tasks into subtasks and allocating each of subtasks for execution. Processor perform the execution of subtasks concurrently. So then data level, third one is a DLP, data level parallelism. So here DLP, instruction from a single stream operate concurrently on several data limited by non-regular data manipulate pattern and by memory bandwidth. Okay, so this is about the types of parallelism. So instruction call होगा particular processor call the instruction here, then टास्क से डिवाइड होगा पर्टिकुलर बीट से, वो साइज इक्वल होगी, सेम होगी, बट वो डिवाइड किया गया रहेगा. ओके, एंड डेटा में एज आई सेड. ओके, देन व्हाई पैरेलल computing we are using here? The whole real world runs in dynamic nature. That is, many things happen at a certain time, but at a different place concurrently. This data is extensively huge to manage. Okay, huge to manage. Real world data needs more dynamic simulation and modeling. So simulation means what? Suppose you want to make a car physically, means actual in the real world. But if you do some mistake while making a car, yeah, preparing particular process, या कोई भी working करने के लिए अगर आपने कुछ mistake किया, then you will waste the money. But in case of simulation, first of all you design through the software, through the net, then you able to, if it is perfect, then you can able to design, you can do launch in real world also, right? So simulation work here. So simulation on modeling and for achieving the same parallel computing is a key of parallel computing, provides concurrency and save time and money. Okay, parallel computing क्या करती है? Money और time को save करने का काम करती है. So you can say it is an advantages also in parallel computing, save money and time. So parallel computing provide concurrency and save time and money. So complex large data set and their management can be organized only and only using parallel computing. So ensures that effective utilization of the approach's resource, the hardware is guaranteed to be used effectively, whereas a serial computing only some part of the hardware was used. The reset is ideal. Also, it is impractical to improve real-time system using serial computing. So here, hardware architecture is there. Okay, hardware architecture of parallel computing is there. So here SISD, that is single instruction, single data. So S for single instruction, I for S for single, I for instruction, and S again for single, D. मतलब single instruction, single data. So this is about single instruction, single data. You can see here. सिंगल इंस्ट्रक्शन में सिंगल डेटा प्रोसेस होगा यहाँ पे इंस्ट्रक्शन पूल देन डेटा पूल एंड प्रोसेसर मतलब प्रोसेसर डेटा को पुल करेंगे और इंस्ट्रक्शन को पुल करेंगे और व्हाटएवर दे वांट टू परफॉर्म टास्क दे कैन डू इट ओके सो इन दिस we can say that single instruction single data multiple data okay so SIMD so single instruction in single instruction so here this is a diagram is given all computers single instruction single data and single instruction multiple data MISD and MID okay so we have to study about on this particular diagram so SID is traditional computers there you can see then vector then MIMID is a shared memory and here a private memory and shared memory both this is the share so let's discuss it this let's discuss it okay so in single instruction single data SISD, machine refer to single processor executing a single instruction stream that operates on data stored in a single memory. The single instruction stream, single data stream. So here, single instruction, single data. Okay. So machine refer a single processor. Okay. To executing a single instruction. तो single processor मतलब machine refer क्या करेंगे single processor और वो क्या करेंगे एग्जीक्यूट ऑफकोर्स सिंगल इंस्ट्रक्शन ओनली बिकॉज वो जब वो सिंगल प्रोसेस को कॉल करेंगी तो सिंगल इंस्ट्रक्शन को ही रेफर कॉल करेंगे राइट एग्जीक्यूट करेंगे तो दैट ऑपरेट्स अ डेटा स्टोर इन सिंगल मेमोरी सो जो कि सिंगल मेमोरी में स्टोर होगा राइट मतलब सिंगल इंस्ट्रक्शन सिंगल डेटा में ऑफकोर्स डेटा भी इंस्ट्रक्शन भी सिंगल कॉल होगा सिंगली कॉल होगा डेटा भी स्टोर होगा सिंगल और सिंगल मेमोरी में ही ये वर्क मतलब इन वन टास्क वन मेमोरी वन इंस्ट्रक्शन okay it comes under SISD so single instruction stream single data stream single instruction stream a multiple data stream that is a SIMD so multiple instruction stream single data stream multiple instruction SISD stands for single instruction and single data stream it represents the organization of single computer I said already so contain the control unit a processor unit and memory unit instruction are executed sequentially, and the system may or may not have internet parallel processing capability. In computing, MIMD, this one, MIMD. So MIMD is a multiple instruction and multiple data. So is a technique employed to the achieve parallelism machine using MIMD. Have a number of processors that function a synchronization and independently at any time different processor may be execute different instruction on different piece of data so here multiple मतलब multiple times वो processor different मतलब multiple processor they can use multiple instruction they can use and multiple performance they can perform in multiple memory okay मतलब number of memory number of instruction are placed in MIMD right so here multiple instruction and multiple data refer to a parallel architecture. Why? Because serial architecture always perform any task in sequentially, right? So here this MIMD refer parallel architecture, which is probably most basic, but most familiar type of parallel processor. Its key objective to achieve parallelism. MIMD architecture includes, you can say, a set of individual tightly coupled processor. So there are two types of MIMD architecture, distributed MIMD architecture and shared MIMD architecture, shared memory. So is MIMD better than SIMD? So we know that SIMD is a single instruction, multiple data, or MIMD is a multiple instruction and multiple data. So MIMD is a more efficient in terms of performance than SIMD. So the main difference between SIMD and MIMD is that SIMD has single decoder whereas MIMD has multiple decoders. So what is MIMD used for? So in computing MIMD, multiple instruction, multiple data. Okay, so is a technique employed to achieve parallelism. So mechanism using MIMD have a number of processors that function asynchronously and independently at any time. Different processor may be execute different instruction on different bits of data. So what is MIMD parallel computing? So मतलब MIMD का रोल क्या है in parallel computing? So MIMD stand for multiple instruction and multiple data stream. So in this organization, all processor in parallel computers can execute different instruction and operates on various data at the same time. In MIMD, each processor has separate program and each instruction stream is generated from each program. Okay, so what is SID, SIMD, and MSD? MISD. So SISD, SIMD, and MISD. So single instruction stream and single data stream. SISD is a single instruction and single stream and multiple data stream, that is SIMD. Okay, so multiple instruction stream, single data stream, MISD. मतलब single SISD मतलब this is a single instruction stream and single data stream. SISD here not given. So SIMD, sorry, SISD over. SIMD is a single. It is a stream, multiple instruction. Okay. So stream, single data stream. MISD is a multiple instruction stream and multiple data stream. So what is the difference between SISD and SIMD? Let's discuss the difference between these both. So SISD or single instruction single data processor are basically equivalent to two people given the same jobs. Okay, with the exact same specification. Okay, SIMD is or single instruction. Okay, so here jobs is so here two people give the same job with the exact sum specification, and SIMD or single instruction multiple data on other hand, like two people doing the same work but different specification. So here what happened, SISD is a single instruction. So is for example, two people give the same job with the exact same specification. को दो people को job मिली, it comes under SISD. Means job या task means two tasks performed in same means you can say one task is performed in same same processor. Okay, as two tasks performed in same processor, and SIMD is a two tasks performed in different processor. Okay, so why MISD is not used in real time? MISD organization computer are rarely used, but for the specification application, real-time computer need to be fault tolerant, where several processors execute same data, productivity and redundant data. So element of so this is about our your all computers. Then elements of distributed computing. So here elements of distributed computing. So in the previous okay, so in the previous section we discussed techniques and architecture that allow introduction of parallelism within a single machine or system. Okay, so that allowed instruction or parallelism within a single instruction and machine or system, and how parallelism operate the different level of computing stack. Here, extend the concept of explorer how multiple activities extend the concept of the how multiple activities can be performed by system. Compose multiple heterogeneous machine and system. We discuss what is generally referred to as distributed computing, and more introduce the most common guidelines and patterns for implementing distributed computing system from the perspective of the software designer. So component of, so you can see that here processing local memory processor, then local memory processor is how to communicate with through the channel. So distributed computing मतलब particular task को कैसे communicate कर रहे हैं हम लोग यहाँ पे, you can see it. We have studied about distributed system in my previous lecture, right? So this is the only यहाँ पे computing मतलब networking से connection, local memory कैसे processor से connect है, this all is there here in distributed computing only. Okay, so component of distributed computing here. So this is about the component of distributed computing. So let's discuss about the components of distributed computing here. So okay, component. Okay, so here block storage provider, client driver, then security provider, metadata service. Metadata service is nothing but it is the data about data service, right? So and data about means give the information of data. So here distributed system architecture, a component, a modular unit with well-defined interface, replaceable, reusable. Connector, a communication link between modules which mediate coordinate or cooperation among the components. What are the components of monitoring system in a distributed system? A monitoring solution for distributed system is composed from various elements such as monitoring layer events, threshold pooling, intervals, and data iteration. The layer represent where the data are collect from the how it is transferred to the monitoring system, and eventually where the results are presented. So architecture system style for the distributed system is that is software architecture system. Software architecture system and system architecture system architecture styles. Sorry, system. This is a system architecture style. And this is the software architecture style. Okay. So these are the both types of architecture system. So you know that now the distributed system is component a modular unit with well defined the interface, replaceable and reusable. मतलब यहाँ पे distributed system ये we can do interface, well defined the interface, replaceable and reusable. So connector, a communication link between modules with coordinate or cooperation among the components. So here the two types are there: software architecture style and software system architecture style. So what is the software architecture styles? The architecture style is a very specific solution to particular software which typically focus on how the organization, the code create for the software. The organization, the architecture pattern in the description of the relationship type and elements, along with the set of constraint to the implement of software system. Okay, so here the architecture style is very specific solution to particular software. Is a very specific solution. मतलब is the first software architecture is used to the find the particular solutions. Okay, then system architecture style here. System architecture style. The architecture style is a you can say the architecture style is a very specific solution to the particular software, which typically focus on how to organization and code create the software. The architecture pattern is description of relationship type and element along the with the set of constraint to implement a software system. So here, so so this is about the software architecture style, and this is the component distributed system. So system architecture, I said that a system architecture is a style is very specific solution to the particular software, which is typically focused on how organize the code create for software. मतलब सॉफ्टवेयर का कोड कैसे क्रिएट कर रहे हैं फॉर सॉफ्टवेयर के लिए ऑर्गेनाइज करने के लिए. एंड द आर्किटेक्चर पैटर्न इज द डिस्क्रिप्शन ऑफ रिलेशनशिप विद टाइप्स elements along with the set of constraint to the implementing of software system. So this is about the system architecture styles. Okay, so here in system architecture style, you can say that here a particular advantage is also there. What is the distributed system? The here layers are given. So here hardware is given, layers of the distributed systems here. In the layer, you can say that uh, in hardware. So you know what hardware is the role. Okay, so at every level, you can say the network hardware continue physical infrastructure. So you know it very well. Whatever हमें cloud में या हमें कोई भी system में we require the hardware to do the any task. If you want to do code, then also you require the keyboard and all. So these components are directly managed by the operating system, which provides basic services for inter-process communication, process determinations and management, and resource management in the context, okay, of file system and local devices. When the data together, these two layers become a platform above which special software is deployed to the turn on the set of network computers in a distributed system. So operating system is a two-layer. Second component or layer in the distributed system is the use of even more non-standard of operating system. So, for example, network connectivity between different devices is controlled by standard which allow them interact natively. मतलब अगर दो डिवाइस के बीच में जो भी कनेक्शन होना है, of course this is depend on OS. Without OS, how particular device can perform, right? So here operating system also well a vital role in this. Then at the operating system level, IPC services are applied to standardized communication protocols such as TCP, Transmission Control Protocol, which we have studied in my IP lecture only, and Internet Protocol IP, User Datagram Protocol, other. Okay, so this all protocol is used to the for communication purpose only. Okay, so middleware, you know the work of middleware in computing system, right? So middleware is working here. All of them have format in uniform interface for distributing developers that is completely independent from the underlying operating system and hides all the objects from bottom layers. So middleware provides different features to application according to the type of service sold to the customer. So application the top of the distributed system stack is represented by application and service design and deployed to the use of middleware. So here one of the practical, let's see. Let's go. Let's check. I require. Okay, just 1 minute. Let's discuss about the practical session here. So, cloud, GCP, Google Cloud Platform. Let's discuss here. Google Platform is there. So through this, I said we can do the billing. We can store any data like that, right? So let's discuss about Google here. Console is given. We have to go on console. Okay. Okay. Stretch time little bit. So after console, so it is your second practical in cloud computing. Okay. Okay. Let it works. It takes some time. So okay. Okay. Just wait. Okay. So here, um, neat. So here you can see the we got the new project option. So we can click on it on new project option, and then after we are able to see go to home. We are able to make a project. Okay, so here billing is there, network connectivity. It takes time. Wait. Okay, so here see here I can make the new project. Okay, and already I have made many projects here. So with the help of this we can I can upload any project with the help of GCP Google Cloud platform. I can do billing someone whatever बड़ी से बड़ी organization for monitoring purpose. Then here you can say that new okay, take the cloud and click on new project. Okay, after new it will come. You can give the name and you have error reporting, then news documentation, learn about the engine document. You can do it. Then getting start. Then see here project name. जो भी हम देंगे cloud, then project number and project IDs. Add one more project, then you can add it to give the any project name, and you can give suppose TYCS CC. Okay, so TYCS CC I created project. तो ये project create करने के लिए हम लोग ये प्लेटफॉर्म गूगल क्लाउड प्लेटफॉर्म हम लोग यूज करते हैं. So see created. Okay, see all activities. तो ऑल एक्टिविटीज हम लोग चेक कर सकते हैं. मतलब प्रोजेक्ट क्रिएट करने के बाद हम लोग इसमें बिलिंग एक्टिविटीज है, बहुत सी एक्टिविटीज है जिसपे हम लोग वर्क कर सकते हैं. ओके, तो मेरा प्रोजेक्ट हमारा प्रोजेक्ट क्रिएट हो चुका है. सी TYCS select the project, and through this project we can perform the many activities which are there in this cloud platform. Okay, so here हमें just ये देखना था कि हमें हम how to create a project. So we have study about how to create project, and in this you can introduce any activities. See, this much I created. Okay, project. So because of net issue it will take the time. So अपने mail login करने का सी TYCS check. TYCS मेरा project चुका है. फिर यहाँ पे dashboard है, then activities है, whatever you want you can do it through this. Okay, so here you can see the VM instance, matlab virtual machine instance. So you can create this also through this project only, right? So all our activities are there. So first of all, you have to you want to do, yeah, you have to perform make a project. Then we have virtual machines instance. You know, means you know very well the meaning of the virtual machines, right? Then you can introduce any activities you can do through these projects. Okay, so this is about our project. This is about our project. We have studied about mm, okay. So in today's lecture, we have studied about what is virtual machine, and then we see the all computer MISD, SISD. Then we have seen that how to work of SISD in and processor. We already study about processor, right? Parallel computing means what, and it's save the times and money also. Over it is overcome of serial computing, right? So this all the session we have studied in these lectures. If you have any queries, then you can contact me. You all have my numbers. Okay, so today's lecture over here. Thank you.